bonding occur? How does bonding occur? Now, a bond, the bond is formed, let me first. Now, after hybridization, now there are different theories that do explain bonding. And you have the molecular theory, which bases on linear combination of atomic orbitals. We have this linear combination of atomic orbitals, and usually this one is what we normally use, okay, where this orbital overlap between orbitals of this atom or this element and orbitals of the other element. But now that one, we shall not talk about the theories because that's not ADF. Okay? We shall not talk about the theories. But we shall use the concept to explain bonding without talking about the theories. Now, a bond or bond formation is due to overlapping of the sp3 hybrid orbitals that have been formed from hybridization of the carbon atom and the atomic orbitals of the other atom. So it is basically orbital overlap, okay, as we are going to see. And if these orbitals do overlap, remember these orbitals must have unpaired electrons, but however, the unpaired electrons must be in parallel but opposite spins also to enable pairing of these electrons to occur. Okay? So basically, let's see. You have, let me repeat, you have the 2s electron, and the 2s electron has one electron. The other one has been promoted to the 2p and the 2p. So all orbitals have basically one electron. Okay? So now these are the new sp3 hybrid orbitals. Now, for bonding to occur, okay, then the other atom must also have empty, not empty, but orbitals with unpaired electrons, okay, and these orbitals must therefore be in some suitable orientation such that the orbitals of this atom, let's say it is hydrogen, and hydrogen it is 1s, and so it has the s orbitals, okay, with just one electron. So the s orbitals must therefore come and overlap. Let me illustrate it with this. So the s orbitals must therefore come and overlap. Let me use this. So this is our new s orbital with unpaired electron, so that this one brings its electron and this electron gets closer to this electron, so that the two are kinda like paired. However, they are from two different atoms. Okay? Then also another one comes in and pairs up with this. Remember, these electrons are in opposite. So these orbitals, especially the p, they are on a Cartesian coordinate. So they have different orientations. Okay? So the orbitals do, these new incoming orbitals, they come and attack them basing on their orientations in space. Okay, and so they end up overlapping to bring about these electrons to cross contact to pair up. So also this one, same thing. So they also pair up. Also this one, same thing. They also pair up. So as a result of this orbital overlap, then a new force of attraction, which is a bond, is going to be formed. And which bond? To be specific, it is our covalent bond. Why covalent? Because it is formed by sharing. You see, the electrons are being shared. But the shared electrons, they are contributed by both parties. All atoms are all contributing. Okay, the electrons. So basically that's how bonding occurs. So let's see how the carbon hydrogen bond is going to be formed, like I've already talked about. So when atoms, carbon and hydrogen are sufficiently close together, okay, and their orientations are enough, then the atomic orbitals of hydrogen, and in fact hydrogen has one s orbital, just one. So that atomic orbital, the one s orbital of hydrogen with unpaired electron, is going to overlap, okay, with one of the sp3 hybrid orbitals, okay, and the result is the formation of a sigma carbon hydrogen bond. Is that okay? Which is a covalent bond that is going to keep these two atoms close to each other. Now, this carbon having four unpaired electrons with an sp3 hybridization, it forms four sp3 hybrid orbitals. You saw them from above, okay? And so these four sp3 hybrid orbitals will require four hydrogen atoms to completely pair up to form an octet structure. Octet structure means having that noble gas configuration. Okay? So carbon has, it is 2s, 2s2, and 2p, 2p2. So if it pairs with four carbon atoms, then the 2p and the 2s is going to be filled up with electrons. And so if it fills up with electrons, then it will become 2s2, okay, and then 2p, 2p6. And this is the electronic configuration of a noble gas. Which noble gas? Neon. So in other words, in nature, elements or atoms will tend to react in order to form that noble gas configuration, which is stable. Okay? They cannot exist alone apart from these noble gases. So they will always tend to react in order to become stable. So basically that is some illustration of the orbital overlap, where this is the carbon, okay, and this is the s orbital, okay, and this is the sp3 hybrid orbital, and this is the 1s orbital, okay, of hydrogen. And this orbital, when it approaches the sp3 hybrid orbital, or one of the sp3 hybrid orbital, then the two are going to undergo orbital overlap. And so when they overlap, they bring their electrons, okay, close together, so that the electrons will end up pairing up. And so the result is a carbon hydrogen bond. Okay? And it is the sp3. It is one of the sp3 hybrid orbitals of carbon that is overlapping with the s orbital from hydrogen. Is that okay? Yes. So please drop your question. Don't worry, feel free to drop your question always. I'll always go and check. Now let's see how the carbon-carbon bond is formed. It is simple, it is the same concept. After forming the sp3 hybrid orbitals, then the hybrid orbitals from the two carbon atoms, they will undergo orbital overlap between the two carbon atoms themselves. Okay? And the result is a carbon-carbon sigma bond. So the combination of the two carbon atoms results from the overlap of sp3 orbitals from each of the carbon atom to form that strong carbon-carbon sigma bond. Okay? So it is the, as long as you know the concept of hybridization, then you can explain anything. So the result is the rest three hybrid orbitals will overlap with the three hydrogen atoms to form your ethane. And the illustration is there. Okay, so you can look at this. So this is one carbon atom and this is another carbon atom. So the sp3 hybrid orbital of one carbon atom is going to undergo orbital overlap with another sp3 hybrid orbital of the other carbon atom. Okay, and so the result is formation of this carbon bond, which is strong enough. Now remember, there were four orbitals, but you are using one to overlap with another carbon atom. Okay, so it means you are leaving a balance of three. So now those three, they are the ones, the three on each carbon atom, they are the ones that will undergo orbital overlap with the four hydrogen atoms, sorry, with the three hydrogen atoms. And as a result, you form the carbon-hydrogen bond, carbon-hydrogen, and so you end up forming your ethane. If it is propane, same thing. Hexane, same thing. Same thing, same concept, same concept, same concept. Okay? Then, how about where we form a double bond? Now that's where the science, some little science is. Now for the formation of a double bond, and you see, there are two electrons, there are two bonds. This one and this one. Now, of the two bonds, one is a sigma bond and another one is a pi bond. And one is formed by normal orbital overlap, okay, of the three sp2 hybrid orbitals. Then the other one is formed by overlap from the atomic orbital that didn't involve in hybridization, as we are going to see. So carbon, oh sorry for that, let me run. So carbon is bonded to three other atoms by sigma bonding. And what are the other atoms? The two hydrogens and the other carbon atom. Okay? Using the three hybrid orbitals. In other words, to form alkenes, to form a double bond, then the carbon is going to undergo hybridization. So let me, sorry for that, somebody was talking to me. So the carbon is going to undergo hybridization where it involves the promotion. So the promotion, sorry for that, somebody is talking to me. So the carbon is going to undergo hybridization, okay, where you're going to unpair the two s electrons, you unpair and you promote to the 2pz. Now after promoting to the p2pz, we say that there is mixing. Now instead of mixing all the three p orbitals, you're going to mix only the two orbitals, okay, with the s, and you leave one untampered with. So as a result, you form three hybrid orbitals, and the three, it is s with one electron and p with two orbitals. So that's why it is called the sp2 hybridization. Okay, so these three sp2 hybridized orbitals, they are the ones that are going to be involved in formation of sigma bonds by orbital overlap, same concept. Okay, and you form three sigma bonds. Now the other one, this one, okay, that didn't hybridize, okay, so hybridization of 2s and two orbitals of the 2p of carbon atom, it is the one that results into sp2 hybridization. That's, I've already talked about it. Now this is okay. Let's go through it. In ethene, sorry for this, the two of the three sp2 hybridized orbitals of carbon overlap with one s orbital of the two hydrogen atoms to form the carbon hydrogen sigma bond. Yes, we talked about this. Now the third hybrid orbital of the sp2, this third, you've used two, there will be a there will be a balance of one. It is the one that will overlap with carbon to form another normal carbon-carbon sigma bond. Now, there is this legend. Let me use some different pen. There is this legend. Are you seeing this? In the 2px. This one that didn't hybridize. For it, it was rebellious. Okay? It didn't want to hybridize. So that legend, okay? So it leaves on each carbon atom one unhybridized 2p orbital. Okay? This one. Now, these 2p orbitals are parallel to each other if the carbon atom bonds to another carbon atom, okay, to form a sigma bond. Then the 2p orbitals, they will remain on the carbon atoms. So they will remain parallel to each other, okay? They will remain parallel to each other, like how you're seeing. And so since they are parallel to each other, then they can therefore also overlap among themselves, okay? They can also overlap among themselves, okay? They can also overlap among themselves. I mean these 2p unhybridized atomic orbit. And so if they overlap among themselves, then they will end up forming the molecular orbitals. And the two electron, remember this one is bringing one, and this one is also bringing one. So these two orbitals that will occupy these molecular orbitals are referred to as the pi electrons. And so the new bond that is going to be formed is called a pi bond. Is that okay? Yes, and the illustration is there. So let me first erase some ink. So you have, this is the hybrid orbital. Let me get some pen, some different pen. So this is the hydrogen orbital, and it is undergoing orbital overlap with the sp2 hybrid orbital of carbon. Also this carbon, it is also doing the same. Actually, this is for a triple bond. Sorry for this. Sorry for this, but this is for a triple bond. Okay? It is supposed to be down. Now, it leaves now for, let's talk about it. Let's talk about how a triple bond is going to be formed. It is the same concept. The carbon is going to undergo sp hybridization, where you promote the s into the 2pz, okay, the 2pz from here. So this one remains with 1, then this has 1, this one also has 1, and this one also has 1. Now, after you have promoted, then one s orbital is going to overlap with, is going to mix, is going to hybridize with one p orbital, leaving two unhybridized atomic orbitals. Are you seeing these ones? They are unhybridized. So the s, it is going to be hybridized with one p orbital. So these two are at the same energy level. So because it is one orbital of s hybridizing with one orbital of p, then we call it sp hybridization. Okay? Yes. Now, these hybrid orbitals, okay, if carbon approaches another carbon, then it is going to use one of them, okay, to undergo sigma bonding or to overlap with another carbon atom. So you have one of the sp hybrid orbitals overlapping with another one of the sp hybrid orbitals to form a carbon-carbon sigma bond. So this, remember, you formed to this one and this one. So it leaves a balance of 1. So that balance of 1 on each carbon atom, it is the one that will overlap with the s orbital of hydrogen to form the sigma carbon hydrogen bond. And the same s orbital on another hydrogen. Is that okay? And so you form this. So this will leave 2 unhybridized atomic orbitals. This one and this one on each carbon atom. And remember, these orbitals, they are parallel to each other. Okay? Parallel to each other. So there is this one and this one. They are parallel to each other. But remember, they are in different orientations. So if that is the 2px, if this is the 2py, and then this will be the 2pz. So this one also will be parallel to each other. So this can undergo orbital overlap with this to form new molecular orbitals. Also, this one can also do orbital overlap with this to form another molecular orbital. So that the electrons that do occupy these new molecular orbitals are referred to as pi electrons. And those which, this one and this one. So as a result, you form one sigma carbon-carbon bond, one pi carbon-carbon bond, this one, and another 1 pi carbon-carbon bond. So which result into 3 bonds, and with 1 hydrogen on each carbon. And so this one is an alkyne. Do I have an illustration?